Good morning, students. Today we are going to study first unit semiconductor diodes. In this unit, let us see first revision of metals, insulators, and semiconductors. So let us see first what is metals. The metals which easily allow the flow of electric current through them are called as conductors. Metals such as copper, silver, iron, aluminum, etc. are good conductors of electricity. So you can see with the help of this diagram. So this energy band diagram, in this energy band diagram, here valence band. In valence band, there are some electrons. And in conduction band, you will observe here also electrons. Okay. And in between, there is a no forbidden gap. Okay. Then insulators. The material which does not allow the flow of electric current through them are called as insulator. Insulators are also called as poor conductors of electricity. Means in this materials, electrons does not flow because of high resistance. So with the help of energy band diagram, we can see that. So in insulators, the forbidden gap is large as compared to the conductors. And you will see here maximum electrons contains in valence band, and in conduction band there is no electron. That's why the current does not conduct. Then let us see the semiconductors. What is semiconductors? The material which has electrical conductivity between that of conductor and insulator is called as semiconductor. For example, silicon, germanium, and graphite are some examples of semiconductor. Let us see the energy band diagram. So in energy band diagrams, here valence band, in between forbidden gap, and conduction band. So forbidden gap of the semiconductors are lies between the conductor and insulator. So it is in between the forbidden gap. And some electrons we will observe in conduction band. So we can say that the resistivity of the semiconductor materials lies between the conductor and insulator. Why it is called the semiconductors. So let us see the next. So then intrinsic semiconductor. So basically intrinsic means pure semiconductors. Okay. It is the one where the number of holes is equal to the number of electrons. Meaning these semiconductors, number of electrons is equal to number of holes. Okay. For example, pure semiconductors are silicon and germanium. Now then extrinsic semiconductors. Extrinsic semiconductors are those where a small amount of impurity has been added to basic intrinsic material. Why we need this? Because intrinsic semiconductor material have a poor conductivity, so that is not sufficient for practical uses. So we have to add the amount of impurity, and that's why the conduction capacity of the material gets enhanced. And therefore, by adding the impurity in pure semiconductors, so that is called the extrinsic semiconductors. There are two types of extrinsic semiconductors: N type of semiconductor and P type of semiconductor. So what is N type of semiconductor? So you can see here, the crystal is used here, germanium or silicon. We know that in germanium or silicons, there are 4 valence electrons in the, and here to get the N-type semiconductor, we have to add the pentavalent impurity. In pentavalent impurity, the 5 valence electron in the outermost orbit. Then these 4 electrons having the silicon and germanium in the outermost orbit and 5 valence electron in the pentavalent impurity. So 4 covalent bonds are made here, but 1 electron is excess. So that is the free electron. So that is free electron. This excess electron is the free electrons. Okay. So you will see here in the diagram. So this is excess electron, what is called the free electron. And these excess electrons are called the donor because this crystal donates the electron. So it is known as the donor. One more thing in N-type semiconductors. So in N-type semiconductors, electrons are majority carriers while holes are minority carriers. Remember this thing. Okay. Then let us see how to uh, get the p-type semiconductor. So in p-type semiconductor, we have to add the trivalent impurity material to the pure semiconductors. So what will happen? So here again we consider the same crystal, germanium or silicon, that having 4 valence electron in the outermost orbit. But here we adding the trivalent impurity. So trivalent impurity such as boron or gallium. So that having 3 valence electron in the outermost orbit, and that's why here 3 covalent bonds are formed, but 1 covalent bond not formed because of deficiency of 1 electron. Okay, due to this deficiency in covalent bond, 1 hole is created. You will see here the hole is created in this covalent bond, and hole has a positive charge, and therefore electron get attracted toward the holes. Okay, but here in whole crystal, number of holes are produced in the crystal, and that's why P-type semiconductor produces the holes. Okay, so in this way, millions or billions of holes produces in the crystal. So in P-type semiconductor, these holes accept the electrons. And that's why it is called as the acceptors, because it accepts the electron because of holes. Holes have a positive charge, and due to this positive charge, electron get absorbed. Okay, and that's why it is known as the acceptor. So one thing is very important in P-type semiconductor, similar to N-type semiconductor. So in P-type semiconductor, holes are majority carriers because in this case, holes are generated here, all the crystals. So holes are majority carriers while electrons are minority carriers. Remember this thing. So these basic concepts are very important to further study. So, we stop here.